Okay, YouTube's up. Oh, I should maybe clarify the title. No, no, no. It's not the last time I'm answering math questions. It's the last time I'm suffering with PDEs. Because the final is on Monday. Okay. It's the end of an era. My last stream ever. No, yeah, I'll just become a DayZ streamer. It's okay. The most mediocre DayZ streamer you've ever seen. No more pie. Nope. What should I change my title to? Hey, Reg put. But the suffering is almost over. There we go. That's a good stream title. Okay. What am I doing? I only just got started, so I was just about to start studying for my partial differential equations final. And this class had 2 midterms, and I was just going to work through both of them. So I've already taken them, so hopefully I remember how to do them all. Well, 2 of them, well, I got 2 of them wrong, but anyway, this is the first midterm. This is the first problem, at least. There's a lot of blank space. I've already got the first one. That's true, Jed. I'm off to a terrible start here. Hey, Skirt. This will be a memorable month. No matter how hard you try to forget it. That's mysterious. Scroll up. Oh, my name? Yeah. What if this is my name? It's just a bunch of underscores. It's what my birth certificate says. Do I watch IPL? I have no clue what that is, so the answer is no. Okay, this question is just a gimme. Can't answer this question. You probably shouldn't be in a PDEs class. To be honest, I do kind of struggle with the second part sometimes. It's not mine. Oh, that's like the worst thing the birth certificate could say. Ugh. Okay, that's a definition of a Laplacian. I do kind of wonder, like, this is in Cartesian coordinates, and that's good enough for the purpose of this class, but, like, I'm kind of curious if this is the actual fundamental definition of the Laplacian, or if it's, like, if there's a way you can define the Laplacian without coordinates. Probably is, but I don't know. An example of harmonic function. Okay, so I remember I did something really messed up here, which it's true, but it's not simple. I did e to the x1 plus x3 plus x5, just all the odd x's times sine of all the even x's. Oop, that's not even. If n is even. And the trick with this is that when you take the derivative of sine twice, you just get the, like, negative sign. And when you take the derivative of e, it doesn't change, so you get a bunch of nice cancellations. But if you're working in an odd dimension, this kind of even odd splitting up thing gets a little bit awkward. And so the part where this gets really crappy is that if you want to make this work for odd dimensions, I just kind of did plus 0 times xn, which is just throwing it away. I think a better answer is I can never remember, which is why I didn't use it. But just the magnitude of x to the n minus 2, I want to say. I can never remember if that's a plus or a minus is my issue, so that's why I didn't use it on this midterm. I mean, actually, I kind of did. I put this as my main answer, but I also said or this or something like that, but I can't remember it. So the theme of my stream is I take math questions from chat. If there isn't a question from chat, I will just choose my own thing to study. Lately, that's just been I'm a grad student, so it's just been my homework. Yeah, and I'd say like the one like caveat is I can't do JEE questions. A lot of people ask about that, and I've tried and I can't do those. So okay, so we're gonna move on from number 1. Let's do number 2. Making pies, true. Also making pies. Okay, for this one, we're gonna define a new function, w. It's twice as good as u. Because it's w. It's gonna be x squared minus u of x. Because we want to... The goal is to compare these two things, figure out which one is greater than the other, so let's take their difference, figure out if it's positive or negative. We're going to take the Laplacian of w. Ooh, that's not how you make a w. I just made a triple u, actually. It's 3 times as good as u. If u is bad, it's twice as bad. That's true. That does go both ways, Jed. And if u is neutral, then it's also neutral. It's doubly as neutral. No, I cannot. So sorry. Okay, so if you take the Laplacian of the magnitude squared, I mean, I know the answer is 4, but let's just actually write it out. It's x1 squared plus x2 squared. It's 3 squared. I don't know why I'm writing out so many of these. So if you take the Laplacian of that bad boy, that you take the derivative of that twice, everything else gets zeroed out. So it's just 2. Take the derivative of x2, this becomes 2, everything else gets zeroed out. Wait. Oh, right. It's an R2. Ha. Okay, unless I check, 2 plus 2 is 4. I thought we were doing it for an arbitrary dimension, but it's an R2. I assume this still works in higher dimensions, though. Why? Because they're too hard. Okay, and then u is a harmonic function, so the Laplacian of u is 0. So the Laplacian of w is always positive, which means w is subharmonic, which doesn't have as nice properties as a harmonic function, but still has some nice properties, like the maximum value principle. That still holds. We do need to think about w at the boundary. So w evaluated on the boundary. See what's the magnitude of x squared minus u of x evaluated at the boundary. But these things are the same on the boundary, so it's equal to 0. So then we say by the maximum value, that's not, oh my god, I can't make u's. Principle. JA questions are just different. They're annoying trick questions that if you don't study specifically for those questions, you can't do them. I don't think they teach you very much actual math. W is constant. Or W is less than 0. Less than or equal to 0. Less than 0. Should be less than 0 on the interior of omega. And then we have to throw out this. I'm in America. We have to throw out the constant case. Cannot be constant. Because the Laplacian is 4. So W is less than 0, which implies x squared minus u of x is less than 0, which implies x squared is less than u of x, and we're done. Zach, thank you so much for the raid. I hope your stream was good. I was working on you. My gold first brain already forgot what you were doing. I remember you were ending with some graph theory stuff though. Peach Tea hate, Mean Machine Rex hate. Actual education's dead. Oh, sorry. Yeah, that happens. Got a math question for you. It says, let's say I have a $200,000 worth of Star Wars Lego I want to sell. Do you actually? I did not know about your Lego hobby, if that's true. You are prompted to set new goals and discover new desires. Ooh, that's a nice fortune. You can put it there in chat, or you can put it in my Discord if you have a question. Oh, I'm out of... Oh, that's a reference? Oh wait, I think I think that rings a bell. He was, I forget why. Like, wasn't he in some sad situation where he has to sell his Legos? I forget. Money wise, you are lucky this month. Ooh, that's a good fortune too. So yeah, what's happening on the stream right now, unless we get a question, is I have a PDEs final on Monday, and I need to study for that. So I'm working. The professor posted the midterms, like just the actual like God, I'm doing a terrible job explaining this. There were 2 midterms in this class. The professor posted them so we could use them to study, and so I'm working back through those 2 midterms right now. I'm currently in the first midterm that's just about harmonic functions. And so yeah, it's consignment agreement gone wrong and the franchisee was booted. Okay. Does del omega mean like the boundary of limit points? Yeah, it just means the boundary, pretty much. Okie dokie, artichoke. So we did number 2 here. I'm gonna pull in number 3. Because d omega looks cool. I guess it's cool enough. I had no clue what it meant for a pretty long time, and it was really confusing. But I figured it out. Hey, Fembox. Hope you're doing well. Ooh. This song's cool. Okay, so harmonic functions are C infinity. How does this go? The first thing is for harmonic function u. Okay, let's first off say let phi be a mollifier, and a mollifier it just has certain properties. It has to be radial, it has to integrate to 1 over its domain, it has to be compactly supported, and I think that's it. You can prove that the convolution of u, a harmonic function u, with any mollifier, you just get your same function back out. And mollifiers are cool because if you do a convolution, it kind of smooths out the function. And so what this statement says is that u is already smooth. D omega is do. Oh, I was wondering where you were going with that, Chad. Don't mega. Okay, so yeah, so let u be in, I think C2, which just kind of comes from the definition of a, like, that's like the minimum you need for Laplace's equation to be well defined, I think. And let's actually, this feels a little, no, okay, never mind. I'm trying to figure out the best way to phrase this. I remember what the idea is. Then u star phi is in C3, but u star phi equals u. So you are in C3. Yes, you. And then you can also just do u star phi, star phi, star phi, yada yada yada. It's equal to u is in C K or any natural number k. Hence, which is a fun word, u is in C infinity. It's kind of like induction-ish. Let me check what this ping is. Okay. That's number 3. Let me pull in number 4. This is a fun one. Number 4. And that's what Actual Education said. If you do post a question, just let me know. I haven't seen anything yet, but I'm trying to keep an eye out. Okay, we got good old kidney bean domain. So yeah, I was kind of overthinking the first part of this question when I was doing this midterm. So, because I felt like it was almost a trick question. The maximum value principle says that the maximum and minimum must occur on the boundary. But that felt too easy, and so I was thinking like I should also name a point in the interior. So I kind of said something about like, you know, it's not quite true, but like if you want to restrict yourself to the interior, like you can think about the maximum as happening like as close to the boundary of 1 as possible while being as far from the 0 boundary as possible. So I was thinking like somewhere around here. And I think you can make that doesn't, it's really not true what I said, but I think you can make a statement about like local averages that would be true. Like not at a point, but in like a little neighborhood, it would have a higher local average than like down here, I think. Okay, I see you posted it. Didn't Zach do this question for you? It says briefly. That's true, Jed. Yeah. Maybe this isn't the same question. Okay. Why did this get so messed up? Okay, there we go. That's better. Let me get the second image. Okay. So we're given two vectors A and B. Use the grid to construct the sum A minus B. Was there a little thing that got cut off after that? Let me check the original image. Oh, okay, no, never mind. It says the word first, I think. Okay, so we're given A, we're given B. We want to get A minus B, and I think they're telling us to kind of do it one step at a time. Okay. Vectors are great. So if this is our vector B, if you want to get the vector minus B, you just flip the direction. So if positive B is like that, negative B is the exact same thing, but mirrored. And it goes down 1, 2, 3, 4 to the side, also 4. So 1, 2, 3, 4, 1, 2, 3, 4. Something like that is minus B. And so now you just pretend that like minus B is the vector that you're working with, and you can just do addition now, because subtraction is the same thing as adding a negative. Check that count again. Do I not know how to count? 1, 2, 3, 4. 1, 2, 3. Oh, thank you, Jed. I don't know how to count. 1, 2, 3, 4. 1, 2, 3. I feel like I messed this up again. Wait, did I? I think I drew it right, but by accident. I think I counted wrong twice in a row. So I accidentally fixed my mistake. Okay. That's true, yeah. Okay. Didn't realize you had to follow the formula. It's just making sure that the direction is the same, I guess. That's like why it's good to count there. Okay, so let's draw A is normal. We don't have to do anything special with A, so we can just draw that as it is. 1, 2, 1, 2, 3, 4. I'm gonna call this the origin because they don't give us an origin. 1, 2. Oh wait, oh, I'm already up to a bad start. Gives us space for minus B. True. So that's the thing with vectors. No. A is like A is just A. That like vectors aren't strictly positive or negative. We could talk about negative A, but it's not inherently positive or negative. Like it, you kind of have to forget about that idea. Because when you have different directions, positive and negative aren't as clean. Well, so the thing that we want at the end of this is a minus b. So we need to, and I'm thinking of it as doing a plus negative b, because that's just the definition of subtraction. And so a doesn't have a minus sign in front of it at all, so we don't need to do any flipping. And so in vectors, like putting a negative sign in front of b, it doesn't like it's not the same thing as oh, it kind of is, but like when you're just talking about regular scalar numbers on the number line, 1, 2, -1, -2, there's a very clean division between positive and negative numbers. The same thing does not exist for vectors. You can there is no notion of positive and negative like this, because you could have like mixed, or like if you're in this quadrant up here or this quadrant down here, let's say like this one up here is -1, 1, and this one down here is 1, -2. Like each of these vectors has one positive component and one negative component. So like you can't really call these vectors positive or negative. And it's actually really, like, not that helpful to do it either. And so I hope I'm not confusing you more by saying that. I think that's what you're I feel like that's what you're kind of maybe thinking, but maybe I'm misunderstanding you. We have A and B. Yes, okay. So let's talk about that. So now we're just doing good old vector addition, as you've probably seen, but we're doing it with A and we're doing it with negative B. So we can just forget about this B down here completely. So let's start out by drawing A. We said it's down to left 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. And then B, we said it's up 4 over 3. So, and we're tip to tail. So the tip of A to the tail of minus B. 1, 2, 3, 4. 1, 2, 3. Minus B. Thank you, Jed. Yeah. Okay. And then the sum of these two vectors is just connecting where you started to where you ended. So it's going to end right at like that point right there where minus B ends. Drawing's a little bit sloppy. Why can't we put minus B at A's tail? I think... Well, I think that's for subtraction. I think that might be a way to do it too. Shoot, I was getting mixed up with these rules, to be honest. I think you're asking like, why can't we do? Oops. If A is here, why can't we put minus B up here? And then I assume you want to do something like that. I don't think that. I think that gets you the wrong answer. I don't know if that gets you a different answer that's right for another question. I think it just doesn't mean anything, to be honest. I do sometimes forget how these vector rules work, aside from addition. I think so, yeah. Like, uh, the tip of A goes with the tail of B when you're doing this. And so this is where my sloppy drawing kind of comes back to bite me, because we need to figure out if this is the origin here, we need to figure out the end point over here. So it's right there. So it's over 1, 2, 3, 4, 5, 6, 7, and it's up 2. And sorry, I should say left 7, up 2. So the horizontal component, because we're going left, that means negative. So minus 7. The vertical component is up, that's positive. So that's 2. If you're able to make a microwave that makes things hot really fast, can you theoretically make a reverse microwave that makes things cold really fast? Not sure. That's a fun question to think about. I would bet it's much harder to do that. Maybe it's just not possible. Like, I think a microwave is like firing whatever microwaves fire at food. It's hard to make something fire at you, though. Not possible until now. Why is it 2? Because we're starting from the origin here, and where we ended up is 2 above the origin. So when we were counting over, it was 7 left. 1, 2, 3, 4, 5, 6, 7. But then we went upwards 2. So that's why that's the vertical component. Yeah, and as someone says, you think about like A brings you down 2, but minus B brings you back up 4. Exactly, yeah. That's what they're asking you. That's exactly what vectors do for you. They track displacement in 2 directions at the same time. And so you can always go back to thinking about it like separately. Thank you for the follow. That alert gets me every time. So yeah, I hope that makes sense. Let me know if you have anything else that you want to ask about this question. So heating soup for 2 minutes is way too hot. It'd be nice to use the same device to cool it down for a minute. Oh man, but would it be like an actual microwave and like make things cold really unevenly? You could make some really demonic hot pockets with that, I bet. It's like a hot pocket is lava at the ends and frozen tundra in the middle. So imagine what would happen if you make a hot pocket like that and then you put it on the cold setting. Like, what would happen after that? Liquid nitrogen sprayer? Yeah, that might do it. It would be a 3D vector worth the same way as the Z component? Yeah, exactly. Rest has a peaceful effect on your physical and emotional health. That's true. Pierre won't let us answer that question. Okay, so I'm gonna move on and go back to studying, but let me know if there's anything else. Actual education's dead. Great job on your son, by the way. Proud of him? Yeah. Okay, so for this kidney bean domain, we get the maximum on the upper part of the boundary. We get the minimum on the lower part. This study on tile sets, specifically blob tile sets, is really cool. Let's see what's up with this. I wish this font was just a little bit thicker. It's like I don't know. Control plus. I mean, that doesn't quite help. But actually, it might help you guys on the stream read it though. A grid defines a collection of cells, basically a bunch of hollow shapes in space, which connect to each other. Tiles are things you insert into the cells. So this person's talking about Unity, so they're kind of a game dev mindset here. See, it goes across the whole map. Sure. I assume that the shapes in these tiles don't... Yeah, okay, this is more like... I was kind of confused by like why these shapes are here like that, but yeah, it's just kind of so they're distinct, I think. The actual shapes aren't that important. The blob pattern. Wang tiles? What is a Wang tile? Two edge, two corner. Oh, okay, the founder. What about this is a blob? I don't know. Do a minesweeper? So wait, is there part of this? This is a little bit long for me to read through entirely. Like, is there a certain part that you want to like talk about? Not sure. In the meantime, I'm gonna do that minesweeper. Oh, okay, okay. Fair enough. I'll oh yeah, no, that's completely fine. There's no one else who's like waiting. Um, I'm not gonna read the entire thing, but we can keep reading a bit more. I always appreciate when people share like what they're interested in. I don't always understand it, but um, ooh, I almost accidentally hit a bomb. There we go. That might be one of my best times on this site. I have so much free time? I wish I had free time. I'm a freaking grad student, at least for another week. Hey, Obi. Got really curious about tiling in old games. RTC is my childhood. RTC. I don't remember what that stands for. This article is also general, but very cool. No, never mind. I was about to say Roller Coaster Tycoon. That's not RTC though. It's not random. The numbers tell you how many bombs are in like the grid around it. So, like this 2 right here means there's 2 bombs somewhere like immediately by it. And so they happen to be right there. And I've done too many Minesweepers in my life, and so I can just look at a part of it and instantly know what's a bomb and what's not. I have 6 quests to complete. I do? Oh, I do. Yeah. RCT, Roller Coaster Tycoon. Okay. Show me your ways. I mean, there's not that much to it. It took a while to figure out like what the patterns are. But once you know that fundamental thing of like they give you the count of how many bombs are by them, you can figure the rest out. Out for a camping trip. Ooh, nice. Yeah, it's going good. Just trying to get through my finals. Well, I only have one real final. I spent half this week writing a 7-page paper about cancer modeling, which I was really interested in, but it was also a pain in the ass to write that. This is what a Minesweeper quest looks like. Camping sounds nice though. Hope that's going well. Yeah, I want to post it once I turn it in and get my grades back. Because I really enjoyed the topic that I chose. But there's a 7-page minimum for it, and after like 3.5 pages, I feel like I had said everything that I wanted to say. So I had to really stretch to hit those 7 pages. I never heard of Transport Tycoon. Oh, 2.5D. That's a cool way of calling this type of graphics. Like Factorio is 2.5D by this like terminology. Bring out the thesaurus. I did have actually. I use such repetitive language that I actually had a thesaurus up, a tab open for pretty much the entire time. Yeah, I've never heard 2.5D before, but it makes perfect sense. Defining Transport Tycoon terrain. Oh, okay, and the height depends on the corners. Oh, are there 2 heights? Or why is that a 2? Oh, there are 2 heights. I see. Okay. Perlin noise. I've heard of that. Oh, that's cool. Change Tycoon was a Chris Sawyer game published by Microprose in 1994. OpenTTD is an open source version that's free on Steam. I actually just read about OpenTTD. Chris Sawyer, he's not God. Oh, Christ Sawyer! Like, dang, Jed, you really like Transport Tycoon. Got stuck on the constraint parts, got somewhat close in the generation. The entire game was made in assembly. Oh my, that's impressive. Assembly is not fun. Played a fair bit of it. Makes sense. By contrast, the diamond square algorithm naturally lends itself to grid-like terrains. Diamond square algorithm requires high amounts that are square in shape. Have sides of length 2n plus 1. For a 94 game, this sort of makes sense. Yeah, I don't see any issues with this so far, at least. Chris Sawyer knew to do this or figured it out prior to a lot of this being done, just kind of wild. Oh, assembly. Okay. German RPG geek, welcome in. You have OpenTTD, it's a bit tough to learn in the beginning compared to more modern city builder games. Fair enough. Yeah, I assume like in 94 you want to write something in assembly because you can save a lot of memory. But I don't know. So we're doing a 5x5 grid. A random potatoes, hell yeah. Setting the corners to random heights. Diamond step. Set the center to be the average value of the 4 corners, plus or minus some random value. Okay, so first they're random heights, then you average them out, which kind of smooths things over. And that's related to mollifiers. Wouldn't you to know it. Plus or minus some random value. Square step. Set the center of each edge to be average value of the 2 nearest corners in the center. Oh god. Set the center of each edge to be the average value of the 2 nearest corners. I thought we can only talk about the corners, not how do we set the center of an edge? And also, how do we set the center? Yeah, I don't know, Notcher. See the triangular split. I don't see the triangular split, unlike the one high. Well, yeah, here. But, like, if you want to set the center to be a certain value, don't you have to mess with the corners to achieve that? Like, if you want to raise the center of the one high, you need to make a ramp, maybe? Or a 3 high? Or maybe a steep? This reminds me a lot of Factorio, but more complicated, which is kind of impressive. And I still need to beat the DLC of Factorio. I still want to do that. Maybe that's the constraint part? Honestly not sure. I'm not sure. I'm kind of confused by how this person is phrasing the algorithm here. This is cool. Sod, usually people do that. They give me very tough questions I don't know how to do. I'd rather not. Oh, that's clean. That's really satisfying to look at right there. Oh, this is... Wait, never mind. They do, Jed, yeah. Four corner points of the array must first be set to initial values. Two-dimensional square array width and height 2 to the n plus 1. Until all array values have been set. For each square in the array, set the midpoint of that square. Okay, this makes way more sense. Just think about it as an array. You're talking about the first paragraph? Maybe? I don't know. Random midpoint displaced fractal. Okay, so the person didn't do. I think this explanation isn't like they skipped a step in their explanation here, which is why this is confusing. Well, let me explain how I'm understanding it. So, think of your height map as just an array, and I'm going to make it a matrix. Well, arrays. In this case, it's the same thing. Let's just, and let's have some random values that populate. We'll make it 5 by 5. Humans are kind of the worst at RNG. This is... I don't know. It doesn't need to be good. We just need numbers to talk about. The third value is the midpoint? Maybe? We're talking about that. So the diamond step. Hey, famished. Each square in the array. So the midpoint of that square to be the average of the four corners. Wait. Why is this a diamond if it's a square? What I'm imagining is the diamond step. I don't know why they call it a diamond step, but I think they're making every possible square like this. And this 0 in the middle is the average of the corners plus a random value. And so maybe the diamond is hidden in here like that. I don't know why they would call that... Like, I don't know why they call that a diamond, though. But I think that's what they're saying. And you, like, take this square and do it every single square you can. How's the math? It's going good, famished. How about you? Is a square a diamond? I mean, it's an angly diamond. It's square. Hey, Roxra. Wait, did I say hi? I don't remember. If not, hi again. Or, never mind. SAT was today. How you feeling? Wait. The diamond step involves a square. The square step involves a diamond? Am I being trolled? Did someone edit this Wikipedia page just before I opened it? For each diamond in the array, set the midpoint of that diamond to be the average of the four corners plus a random value. Okay. That must be a typo, right? But yeah, I guess what they're saying is at first you do the square, and now you do a diamond. And it's the same exact thing, where now these are your corners. You set the 0 in the middle to be the average, plus a random value. Here's some hypothetical SAT type questions. Yeah, sure. And so I bet it's actually not important like which step you do in which order. Um, so weird though. But yeah, this is an interesting thing. This is an interesting way of taking averages of neighbors. Like I don't know why you can't just do the average of all 8 of these at once. Like I don't understand what difference that gives you. Captain Vic, welcome in. Where do I know you from? Because all my streams have the camera on that I can think of. Oh, it's good to have you here. Kind of wild too, because this must have been solved prior to Sawyer using it too. Yeah, I mean, this sort of idea of taking averages of neighbors is it gets used in a lot of places. Okay, this is that's some wild naming. And so if you didn't have the randomness in here, you would just eventually end up with an array that is all the same number. Like it'd be whatever the average is of everything. So I guess that's why you need the randomness in there. Han, so sure, hit me with it. You can put it there in the Twitch chat, or if it's easier, you can put it in my Discord. Heights must be whole numbers, makes sense. Adjacent points can't differ by more than 1 unit of height. Oh, I mean, that's just saying, it's just making sure that you don't have, like, something super steep. Like, if these 2 corners at 1 height were suddenly at 0 height, you would just get some really weird looking terrain. And I think that's what the second constraint is doing. Like, it's making sure you don't have that super weird terrain. So it's probably just for aesthetics than for any, like, mathematical reason. I mean, which the SAT would probably use. uh, okay, I might switch gears away from this notcher so I can talk about what Roxro just posted. This is kind of interesting to learn about, though, with the diamond square algorithm. I'm still so confused about why they call it like that. Yeah, this is kind of cool. Because generating terrain is an interesting problem to solve, and it's applicable in other parts of math too. These ideas. Um, Let me read Hans Soai's question. Why aren't most math books using code to explain the practicality of it? Like, when I look back, a lot of math theories are theory heavy. Code is definitely the implementation. That's a good question, Han. I think the biggest reason is that a lot of math textbooks we use were written before the year 2000. And mathematicians needing to be programmers also is a really recent phenomenon. Um, And I do think that you make a good point that a lot of math, you like understanding the theory could be easier if you understand like numerical algorithms and things like that. It's really true for what I'm learning right now with like partial differential equations. And so I bet we'll see more of that as more textbooks get written. I think for certain parts of math, I don't imagine programming would be all that helpful. Like there's always something you can do with programming, but like for more abstract types of math, it might be of limited help. Sorry, I feel like there's something more that to like get at here too, is what I'm trying to think of how to say it. I think in pure math there's just kind of a resistance to like coding. At least a lot of people have that mindset, I think. Like, or even I've seen people in applied math who feel that way too. Like they just want to do math with a pen and paper and nothing else, and that's fair. Like that's a valid way to want to do math. But it's a pretty popular mindset. Uh, yeah, that's a really good like question though. Physics and chemistry are more written the practical applications during the 1900s, and so many of the math books were written. Yeah, that too. So f of x is this cubic polynomial. If f of 33 is equal to f of w, and w is a constant that is negative. Surely this is an odd function, right? Is it negative 33? Isn't that going to be off? Yeah, okay. I was just worried that that'll be off by a negative sign. Hey, hello world. I'm going to plug it into Wolfram Alpha because I feel like I should just be able to do this mentally, but I'm kind of doubting myself right now. Whoa. It's 0. Is 1089 33 squared? It is 0 though. Oh, your twist memes. Okay, okay. W is negative. F of W doesn't have to be negative. This would not be true. Like, if f of 33 was not 0, I think this wouldn't be true. Because if, let's just say like f of 1, just that's easier to calculate, you'll get 1088. But f of negative 1, you should get the negative of that. Or, sorry, minus. So we get the positive. So if f of 33 is just some random number, this logic would not check out. It needs more salt? True, skirt. Yeah. You're right, Roxra. I agree with you. The answer is negative 33, but it's kind of To me, it's like you have to do a little bit of thinking about it. Like, because this is an odd function, this number w will exist, but you don't necessarily know that it's 33, or you don't know that it's negative 33 unless it happens to be a 0, in which case you're okay. That's kind of mean. So do they expect you to calculate 33 squared on the SAT, or I don't know what they want you to... I don't know what they're up to with that question. Graphing. Oh, okay. That makes it reasonable then. I mean, that kind of removes all the challenge. So you just plug it in and see. Find the value of AB when... Oh god, okay. Just check my Discord. Okay. AB when ax squared plus b is a factor... Oh god. Okay, if we're allowed to use a graphing calculator... Well, wait. Never mind, don't wait. I thought 96 goes into 189, but it's not. Okay, it's all hypothetical. Oh, this is a quartic also. Interesting. The Coriolis effect, just a theory you heard in Call of Duty. Ooh, I remember, yeah, they talked about it in COD 4. Let me get through this question. I don't really know it offhand. I know it's to do with the rotation of the Earth. I don't know anything else offhand, but we can look it up and see what it's like. Okay, so if we're allowed to use a graphing calculator, I'm gonna graph this baby. It's way up here, isn't it? It has no zeros. Well, that's unfortunate. Yeah, I remember that mission. That's one of the best missions in all of Call of Duty. Actually, yeah, no, well, the one right before. Wait, is that included? I don't remember which mission the shot is included in, but like I'll get laid up on where you're sneaking through. It's like the best mission in any Call of Duty. How do you factor this? Yeah, I'll gilly it up. I remember that was a part of the next mission. Oh, we could see this might be a... Wait, 189. It's not a perfect square, I don't think. Wait, could that be 18 squared? No. 17? 17. Never mind. Wait, did I do that right? I wonder if this is a perfect square, because that would save us a lot of work. It's not. You can quadratic formula that. That's kind of a pain. But... Okay, maybe that is what they want you to do. X squared is equal to minus b plus or minus root. So this is A, B, C. Actually, let's keep it generic for a second. I was wondering if there's be an easy way to get A and B over with the X squared. It's not that easy though. Okay. Let's actually plug in the numbers in. 276 squared, bruh. Okay, no, there's no way you're supposed to do that. Lowered you 10 points. Wait, okay. This must be a perfect square, even... Okay. Square root of 96. How do we simplify that? 4 goes into it. 19 times? Because so here's the thing. It's a quartic with no real roots, which means it factors as something x squared plus something times something x squared plus something. And if they just said ax squared plus b, so we have no way of telling which one we're supposed to take. Maybe they happen to have the same product, but I'm betting it's actually just one thing squared. So I'm gonna find out what these square roots are. You are annoying. Does 9 goes into you though? 2, 1. Okay, so I'm gonna take 2 root 19 x squared plus 3 root 21 squared and hope that this equals this. I already know the first and last numbers match by how I made this. That can't work. It's going to be irrational. Crap. You're right, Fembox. It can't work. Then mental math that may be spotty, because 4 times 20. Oh, yep, thank you, Jed. I thought 4 times 20 is 100. 4 times 25 is 100. Wait, yeah, okay, so it's 24. We can pull another 4 out. This may Okay, you know what? I didn't pull the other 4 out. You know who doesn't mess up this math? My good old buddy, Wolfram Alpha. 4 root 6. Oh my god, I just... Okay. I think this still won't work, regardless of that 2 or 4. Also my good old buddy Jed. He was saying this was the hardest set. Factor 3? Oh, before I made it a 3, Michael, I'm not sure. Oh, I mean, from here? Maybe. That could make it a bit simpler. Okay, so we need... I think this is still irrational. Because the number in the middle here is 2 times 4 root 6 times 3 root 21. And that's still an irrational number, and that's definitely not irrational. What the hell, man? Okay, I'm just gonna... Spoiler alert. I'm gonna give it to Wolfram Alpha. Wait, this question is bullshit. Or there's something missing. There's 2 right answers. There's more than 2 right answers. You could answer 72, or you could answer 28. Or you could answer 3 times either one of those. Uh, I don't think we have enough information to choose which one. Like, that's why I thought it had to be a perfect square, because otherwise, how do you choose? There's 2 factors that fit this, so... They could say, like, the greatest one, or the least one, or something. I was wondering if they were going to be clever and have it, like, have one factor be, like, ax squared plus b, and the other one be bx squared plus a, so it wouldn't matter which one you choose, but no. Or some, like, some other combination where the product is the same. Least possible. There we go. Okay. Then the question is possible. It's still really mean. But now it's at least a well-defined question. So this is just quadratic formula, unfortunately. I don't, maybe there's a better way. It's easy. Zero's not a factor of this though. Like neither of these can be 0. A equals 0, B equals 3. Oh, I see what you're doing. Okay, yeah, Jed. uh okay. I mean I think morally you win, Jed. Okay, so since you're allowed to use a graphing calculator, that's, well, if it can do fractions, I would just use a graphing calculator. But you're gonna get 4 answers because it's x squared, and you're gonna have to do a plus or minus when you square root it. But if you do that work, you get these complex roots. And so I guess you want to choose the pair with, like, the lowest magnitude. Root 7 over 2. Root 7 is 2 point something. So 2 point something over 2 is a little bit more than 1. 3 over 2 root 2. Oh, well, that's kind of... Oh, that's also a little more than 1. So you just need to use a calculator to figure out which one is which. Which one is smaller. Okay. 1.0606. 1.32. Okay, so we're using the 3s. So we're going to choose this pair. Well, yeah, so we're going to recombine them. I wonder if there's a way to skip this step, like if you don't need to go all the way down to the complex roots. But I don't know. So we know that this quartic, there's a coefficient out here that's 3. It's actually not that important for this problem, though. It's x minus 3i over 2 root 2. It doesn't factor nicely, I don't think. Does it? Oh, well, actually, sorry. I know that it factors nicely. Ugh. Because I already saw the answer earlier. And then the same thing with these, but I don't care about those. So Jed and Fenbox are saying a better way. My idea was to just multiply these two things out. Minus plus, there's an I, so it's gonna be plus 9 over 4 times 2 is 8? That doesn't make sense. Or do I not want a 3 in front? You know, okay, fine. I'm doing it the crappy way. Jed, do it the way that Jed and Fenbox are saying. This is SATs inherently child abuse. Yeah, this question, it's really tripping me up. It's kind of, it shouldn't be that hard, but it's kind of mean. Uh, 9 2 6 3. Okay, and then just factor this with the good old. It's a number that multiplies to 32 times 63. Yeah, so Roguestar just took the SAT, and these are hypothetical questions that the SAT could have asked, but, you know, who knows what was actually asked. $63 is only 7 and 9. True. Okay. Yeah, that's a great start, Jed, because 63... I mean, you have to worry about... Okay, 3 and 21 also exists. True. So, I tend to fact these by guessing and checking. These will all be pluses. So, these two numbers need to multiply to 32. And these two numbers need to multiply to 63. And then you just mix and match until you get things that give you the 92 in the middle, basically. And I guess we've kind of been spoiled that you want an 8 and a 4 for 32, and then a 9 and a 7 for 63. And then, so we know that these two numbers match. We just need to check the 92. That comes from 8 times 7 is 56, plus 9 times 4 is 32. Wait, no, 36? So 36 plus 56, that checks out. Then the least value comes from that one. Wrong? Well, okay, yeah, or if you're a smart Alec like Jed, you you make that a 0x squared. I don't think that's what they're going for, though. Okay. Yeah, well, if there's any others you want to talk about, Roguestra. Yeah, that's a really mean question. I don't remember the SAT questions being that hard when I took that. I remember them being trick questions. I don't remember them being questions like this, though. Oh, yeah, okay. We can do another. Give them $600 next year. Oh, probably when you need to send your SAT scores to schools and they charge you for each one. Or something stupid like that. Oh, I forget how that works. It's been too long. I'm an unk. Oh, six. Oh yeah, the AP exams. They were $80 when I took them. What was the given correct answer? Yeah. Uh, I guess we don't know yet. Surface area of a pyramid. Let's go to a new page. Yeah, it is still a better deal. Did you? I don't see what the answer is. You answered 31. Oh. Question is asking for the height. Oh, so wait. So does it give you the surface area? What? Okay. So this is like total surface area? Okay, yeah, because it's 64 plus. Okay, okay. Skirt. Is an hour and a half cool? I could do sooner, but I kind of want to get this to be a 3 hour stream. Okay. A right square pyramid. Okay. Cool, cool. Okay, so pyramid has a square base. Oh god, how do I draw a pyramid? Okay, let's show the square at an angle. This is really not important. This is not an art test. Something like that. Okay, so the square has area 64. Yeah, Squirtle, I could use you to do the art. And also apparently the math too. A decent right square pyramid. I think this is decent actually. By my standards. I'll even draw one bigger if you're gonna redeem that. Yeah, sure, Skirtle. Sure. You don't do math. I know your secret. How about that, Jed? Go for a shallower perspective. Hey, you hurt to watch. Okay. Shallower perspective. I definitely can do that. I know exactly how to do that. Is that shallower? No? Wait. How does art work? I don't know. Draw a parallelogram base. Yeah. Okay, wait. I honestly I don't know what you do after this for a shallower perspective. I don't know how drawing things works. I don't know. I'm just gonna do the same thing again, but I don't know what else. Like this front edge feels way too long. Can I bring it down? Can I do? Should I do that? No, because then you can see the back. You shouldn't be able to see the back. Means the angle must be wider? Okay, that makes sense. Damn it. Okay, just draw it super wide. Still a narrower angle? This is a wider angle. Okay, you know what? I'm a gifted artist. I will not have you criticize my amazing drawings, okay? Okay, this is turning out pretty good, I think, if you ask me. You guys are gonna be jealous. Report the stream to the Louvre. Hey, they probably still haven't found whoever stole the jewels or whatever. They're probably still busy with that. I think that's pretty good. It's a little lumpy. It's a little lopsided. It was you. But it's perfect, and I love it. And it loves me. And you know, we'll use this drawing for the problem, too. Who wants this crappy small square pyramid when you could have a giant one? What is this, Jed? This is much worse than my drawing. This is ridiculous. Why would you want to use a drawing like that when you have one like mine? Okay, we should probably actually answer the question. Ugh. Good thing we're not on a timer. Okay, so the square base has area 64, so it's 8. Ban the streamer from Egypt. Ugh, okay. And then each of these 4 faces have okay. The 4 faces in total have area take the total, subtract out the square. Wait, that's a plus. So 16 root 977. But we have 4 faces. Meow. So we're going to divide it by 4. So they set this up kind of nicely for things to work out. Aside from the 977, this is puzzling. Hopefully that comes out to be a clean number. Now here's the thing. For a right square pyramid, do they have to be equilateral? I don't think they do. I assume they are, because I don't think it would be... Oh, they're isosceles. True. Okay, yeah. Isosceles is good enough, I think. We're gonna call the... So, okay, wait. The quantity we want is the height from the top. H. If we want to get that, we're gonna need the side length, capital L. Why not? So the area of... Oh, well... No? I'm just giving the things names. Wait. Make a midpoint on one side of the base. Okay. Wait, are you saying this is the height of the pyramid? That's not the height. I know we're going to. I'm saying the thing we want in the end is this height, but like we're gonna work with this isosceles triangle first, and we have to like cut it in half. So if that's L, and this is half of 8, which is 4, last I checked. It's like, that's what you did too? Okay, okay. And then this is, I guess we'll call it SH for slant height. Why not? Well, we can express slant height in terms of L and 4. Pythagorean theorem. Right, it's an edge to be L? No? Yeah. It's like, hey, Papadoria. Wrong. Wrong? Repomp? Okay. Am I repimg or am I wrong? Or both? What's wrong about this? Both. I preferred being repimg. Pythagorean. Yeah, this is Pythagorean theorem, isn't it? What am I doing wrong? Oh wait, oh, okay. I got mixed up because 4 is already a perfect square. Thank you, Jed. Oh god, I can do PDEs, but I can't do fucking geometry. Yeah, I mean, Jed has streamed in his life. It was before I knew him though. Okay. Not math, but he has streamed. Okay, so the area of this thing, it's half again of that. So it's 2 root 977. It's equal to 1/2 base times height. Now we can solve that for L. I don't know where you're getting that equation from, Roxra. Is that like an equation for the area of an isosceles triangle? The 2's do cancel. Oh, do we get a perfect square after this? I hope we get a perfect square. It's gonna be power of 2? No, it won't be power of 2. And mental math? Mental math? Yeah, okay, 993. I don't think it's a perfect square. It's too close to a power of 2. Nope. What an ugly number. I hope we get a clean number at the end. Okay, so we know L. Sorry, Roxy, I might be doing something completely different from what you did. 8 times h over 2. We only need one more step to find h, though. I don't know where your formula comes from. You did 16 root 977 is the total area for all 4 faces. Oh, but you put the 4 on the other side. Okay, that's fine. 8h over 2. Oh, but how did you find h, though? I see what you're doing now. Okay, so no, we are doing the same thing. I think your h is my root L squared minus 16. My H is your L. Okay. Well, let's hope we get a W. Get it? So yeah, I was gonna form this triangle here. But you definitely could form that triangle. I think they're equally difficult or easy, which depending on your persuasion. We can do the one that you did though. So it matches your work a little better. So the slant height is for that I'm getting. So this is my L. Plugging it into this is 993 minus 16 root 977. Oh yeah, is this a 30, 60, 90 triangle? I think it must be if that's true. This thing down here on the bottom is 4, just half of 8. And then we Pythagorean theorem our way out of this. 977 is equal to 16 plus h squared. Please tell me this is a perfect square. 961? That's no way that's a perfect square. $31. Wow. And that's what you got. Okay. Nice. Dude, I can't even do the Pythagorean theorem right anymore. That's bad. I need to stop frickin' doing grad school math. Draw our RV. Okay. I can do that. Wait, let me get a reference picture. I mean, if it's our RV, it's gotta be really fucked up, though. When I drive, oh, well, when I drive, it's in perfect condition, because I'm just an expert driver. I'm trying to get a good reference photo. I guess this one. RV there yet with the boys. Make it high centered? Okay. Oh yeah, like that one movie. I think it was just called RV. Like this is what comes to mind. Robin Williams. I haven't thought of this movie in so long. On a family vacation, no one can hear you scream. It's trash? I don't remember it very well. Is that a good white? Yeah, it's good enough. Okay, so we want this RV to be high centered. I want to do it like that movie poster. What year was this movie? 2006. Ugh. Wait, did I not? Oh, it just took a minute. 5.6. IMDb scores are normally kind of high, right? That's probably really bad. This looks very obviously photoshopped though. This is like the lighting on the RV is all wrong. Like that's a Photoshop that I would do. Okay. The recent Animal Farm. I didn't know they made an Animal Farm movie. Huh. It's bad. The trailer told you. Okay. Seth Rogen, Steve Buscemi. Oh, it's one of those movies where they just get a bunch of like big name people to do the voices. Woody Harrelson, Kathleen Turner. You found a perfume that makes me smell like a blueberry Danish. Is that a... Oh, I do love a Danish. I would enjoy that. I like a cheese Danish is the best one, but I would take a blueberry one also. Dude, I love pastries in general. All theaters are empty, but some are more empty than others. Okay. Um, Straw Mountain. A mountain. It's a squiggly mountain. Dude, like I prefer cooking to baking, but I bake way more than I cook because I just love like pastries that much. Little snow cap. This is very gray, depressing snow, but it's still snow. Some happy little bushes. I was about to just do a straight mountain, and then I was like, no, I shouldn't make it that simple. That was my first instinct, though. This is bad. I don't think I'm making this better by adding in these bushes. Okay, anyway. Fractals true, Zach. You love baking. I made orange marmalade shortbread cookies. Ugh. You're annoying. That sounds really good. Post it in the Discord. Let me see. Was that recently? Oh, yeah. I remember seeing those. Those do look really good. We should make it bigger. That's what she said. Yo, you made the marmalade yourself? That's even more impressive. That would be a whole process. I have not done that before. I remember my parents made jam once, and that was a like an entire day's worth of work. They canned it, but I think they did a I think they canned it wrong, and a lot of them like went bad, or they jarred it. I don't remember that well though. It's not enough of the whatever you call them, screws, lug nuts, but that's all I have room to include. Okay, what color for the body of the RV? I don't have a very... How does this color show up? A little too light. Can we go shade darker? Oh, what's the lowest IMDb score? That'd be a fun one. It's probably like... It's probably one that just like gained a lot of momentum for people just like hating it. I bet there's a lot of like funny, colorfully written reviews for whatever one has like the lowest score. Oh god. What even is a straight line? Oh god. Uh... Hey, Justin Barheight, welcome in. You you came here at an interesting time in the stream. I hope you're doing well. Food fight. I promise there is actual math happening, just not right this instant. 2012? I never heard of this one. 1.3 though. Zach was not lying. Hillary Duff, Haley Duff. Are they sisters? Charlie Sheen. Huh. Probably good reason? Probably. That dog looks like maybe like a PlayStation 2 dog. Yeah, I don't think I know this movie. Christopher Lloyd. I was looking at his name. I don't know what I recognize his name. Back to the... Oh, Dr. Brown! Marty! We have to go back! Okay. There's a lesser-known sister who also played Isabella in Lizzie McGuire movie. Oh! Covered her vocals because she sucks at singing? Oh no. Okay. I guess we can get some more windows on this bad boy. I feel like I should do a lighter gray for the windows because I'm gonna need gray. I'm gonna need darker gray for the metal bits. I'm putting way too much effort into this. If I'm gonna do something, I want to do it right, though. Okay. Oh wait, we're gonna need a window for the door also. It's getting a little close to the wheel, but that's okay. And the stairs that don't go down far enough. Gotta have those. I wish I colored in the bottom part. Switch channel makes riffs of bad movies like Roller Gator, Birdemic, Fun and Balloon Land. It's your favorite channel? Riffs? Like what kind of riff is that? Okay, I think we're nearly there. Maybe it could use a border. Uh, we need the metal rack. Okay, I think this is a drawing. They commentate. Oh, okay. That yeah. If they're good at doing that, that could be a good time. You know, I just noticed this RV is missing a panel. That's really annoying. This is like a promotional image too. I think I'm calling this a drawing though. Oh wait. Get rid of those dots. Okay. Thank you for the redeem. I guess we'll go back to doing PDEs. Oh, never mind. We're doing a minesweeper. You know, any excuse to not do PDEs, I'll take it. Um. Do a minesweeper. I remember in the Star Fox games, Slippy the Frog was the most annoying character ever. The only Star Fox game I really played was Star Fox Assault for the GameCube, which was a really good game. Uh, and in a bunch of the missions, like whenever he was in like an R wing, he would constantly like say the same voice line over and over again. It's like "No mercy," and it's burned into my mind because he just kept on saying it in his annoying frog voice. Okay. So we did the min, we did the max. We need that level set, which is something like this. Probably a little higher up. Wait, no. I'm getting mixed up with the question on the second midterm. U equals 0.5. Not necessarily exactly halfway between 0 and 1, but somewhere between halfway. Ramen is always a good idea. I mean, if it's overly greasy, probably not. But you should, if you have ramen, you should eat it. Man, I freaking miss the ramen in Japan. Also was probably... So midterm 1, it... which is this is the last question on midterm 1. Ichiran, that place is so cool. Cause I went there twice, and I know they sell like the packs and stuff, but it's for those who don't know Ichiran, it's like it's an introvert restaurant. You have a little like cubby that you eat in individually, and you enter your order into a machine, and then once you sit down, you just like hand it towards like the back of your cubby, and the people there lift up a little curtain, grab it, and like put it back down. It's a really cool experience. Great thing where you can take a 5-hour flight to go shop in Japan. That's true, Skirt. That'd be nice. It was an 11-hour flight on a budget airline for me. That was not fun. So the answer to this is just going to be a straight line. It's going to be y equals x. The Dirichlet principle says, let's see if I can remember this. The function that solves delta u equals 0 with Dirichlet boundary values, boundary conditions, also minimizes the integral 0 to 1 u prime squared over 2 dx. U and f are the same thing. Who cares? And the over 2 doesn't matter either. And so yeah, if you had Poisson's equation, you would have like a minus uf. I should really remember that and look it up. But when it's just 0, it's just that. Yeah, okay. So yeah, I want to see if I can do it from memory. And okay, yeah, cool. Oh, this is actually for a general boundary condition? Oh, yeah, it is a general boundary condition. You just need it. Yeah. Oh, okay, I remember now. Okay. And so in one dimension, the only solution to Laplace's equation are linear functions. Well, yeah, I guess we can even just do it. So the problem becomes u double prime equals 0, which means that u is equal to ax plus b. Then you apply the boundary conditions and you get u equals x. Good enough. There's a bonus question on midterm 1. I guess we can do that one too. Okay. Now, one-dimensional heat equation, well, 1 plus 1 dimensional. The answer is, it's always integration by parts for questions like this, it seems. Well, integration by parts or Cauchy-Schwarz. You know, I feel like t is just an x that's had a linear transformation applied to it. So I just tried to write t, but I accidentally wrote x when I was writing that. So you can Leibniz rule your way here to bring the derivative inside. I'm going to drop the... I was going to say 2u ut dx. Then you can use the fact that u satisfies the heat equation to substitute that ut for uxx. Then you integrate by parts. And I hate doing integrate by parts when u is in the integral already, because then I want to say u and v, but then u is already taken. So we're going to do f and g. F is equal to u. G is equal to ux dg dx. Smiley face and sad face? Oh my, I should actually do that on the final. That'd be really funny. G is equal to ux. He's already spoiled one question on the final. Well, it's kind of a meme question. It's gonna be, what is your favorite theorem? And I've been trying to think of like joke theorems that I can put and then like cross out. So I was thinking like, oh, what's your favorite theorem from class? So I was thinking I should do like freshman's dream and then just like cross it out. Chicken McNugget theorem? True. That'd be a good one. I could do the Harry Ball theorem too. That's one for funny name ones. Pac-Man outside algebra exam and got full credit. Ooh. That's fun. Okay, FG UUX valued on R minus UX squared DX. That's on that question? Yeah. We got full credit. Okay, so this bad boy right here is equal to 0 because u needs to decay. Or well, I guess because f of x has compact support, but I think u also needs to decay. So we just get -2 ux squared dx, and the magic that happens is we're integrating something squared, so it's always, the result of the integral is always 0 or positive. So there's a -2 in front, which means it's always less than or equal to 0. And that was the question. So that's what I was wondering, Zach, because like when you have the heat equation on all of R, don't you have to require that the solution decays at infinity? Like, even if f of x was not compactly supported, wouldn't it have to decay at infinity still? That's what I'm confused about. I don't actually know the answer to that question. Okay. But we're now on to midterm 2, and this one was much harder. So this is the return of the kidney bean domain. Prove that the level set all x and omega such that u of x is 0.974 is not empty. And so what you do is choose a point on the lower boundary where u of x equals 0, and choose a point on the upper boundary where u of x equals 1, such that the line connecting them is contained in omega. Because harmonic functions are continuous, the intermediate value theorem says that u of x must take on every value between 0 and 1, including 0.974. That's the answer for the first part. Is compact support the opposite of almost everywhere? I guess it would be, yeah. Compact support just means it's non-zero on a compact interval. Or a compact set. And it's 0 outside of that compact set. Oh, okay, so the second part of this question, that this set cannot contain a closed loop inside the domain, we did not learn how to solve that question, and he admitted that after the midterm that he shouldn't have asked that question. He named a couple of theorems that would let you do it. We didn't learn any of them, and I forgot what they're called. But we're apparently getting the points back for that question, because he just shouldn't have asked it. I made up something involving the extreme value theorem, but it doesn't work. So I'm just going to skip that second part because there's no way he's going to ask that. The third part is just to draw it. It's going to be something like that. Pretty close to 1, but not on it. Okay, so that was the one kind of gimme for... I mean, not really a gimme, but that's the one question about harmonic functions. Going on to more complicated functions now. Or, PDEs. Okay, so heat equation in Rn, Dirichlet boundary conditions. This one I did not get right. I did ask him about my answer to this after the midterm, and he said I got street credit for my answer, but not actual credit. The thing that I did, what did I do? I expressed u in terms of the fundamental solution of the heat equation. Do we integrate over all of x? I can't remember. Oh, I already used x. Street grade A, official grade C. Well, no. See, here's the thing. He doesn't do partial credit, Zach. My street grade was A, and my official grade on this problem was F. I should take street writing math. Okay, so what I did is I Cauchy-Schwarzed that thing in the middle. And I feel like this should be over omega, right? Surely? This convolution, it probably won't matter. I don't know why I'm writing out my incorrect argument. probably not worth the time. And so I basically said this thing here is a constant because I assume that f has compact support, the initial condition. And I bounded it's like this is just a constant that can come out front. I bounded this by the maximum t that it can attain, so this integral just kind of doesn't do all that much, just multiplies it by the area of omega. And then I think I bounded it again by the maximum in y, or that should be x. Wait, oh, t is also a terrible letter to use. Okay. I basically the fundamental solution decays exponentially in time, and I was able to get the fundamental solution to come out front by bounding it, but that was wrong, and I shouldn't have spent that much time looking for my wrong argument. The way that you're supposed to do this is Rayleigh quotient or something involving that. Okay, so or whatchamacallit, Poincaré inequality or something. It's also like related to the Rayleigh quotient. I think it's this. Inequality goes the other way. Really? Yeah. Okay. I'm trying to remember how this goes without I know where to look to get an idea for the right answer. I want to see if I can figure it out again though. They have a tangy taste. Do they, Koshi boy? So we could integrate by parts on this thing. That's possible. Okay, you know what? I'm going to look at the homework assignment. 10 out of 10 would pair with mayo. Okay. Which one was it? Probably this one? Yes. Okay. So we said most of the class got this problem wrong, and it's because we didn't read the flavor text. In problem 1 of this homework assignment. So actually, by the one problem we just did. What's for dinner? I'm just gonna make frozen food and just get some freaking vegan chicken nuggets and fries, I think, with hot honey mustard. Hey, underscore. Yeah, we definitely need to do that. Um, you know what, Skirtle? I actually would. Send it my way, please. Wait, this is UX squared, though. What I got after the, measure my parts. No, Ichiran is, it's like an introvert ramen, uh, restaurant in Japan, but they also sell, like, packets, or, they sell, like, instant ramen. Oh, okay, so it's actually not quite what we did on, or it's not quite what I did on that bonus problem. 2u ut dx. Or wait, is it? I don't know. This, and then you integrate by parts on that. I think. Yeah, integrate parts on that. Ed Sheeran, true. Man, I feel like since I shaved my hair, or like I cut it short, my Ed Sheeran lookalike game has gotten a lot weaker. Not something I did not think that through. Okay, now what? Uh, the change in time. Keanu Reeves haircut? My hair doesn't grow like Keanu Reeves. Let me look up how Keanu Reeves looks again. Oh, yeah. So the issue with my hair is, so his hair is really well behaved. Mine, it kind of like, it flares out. Like it wants to be curly, but it's not willing to commit to being curly. So it just kind of like goes around everywhere without actually curling. It looks really bad. And I had long hair for like all of high school plus all of college, and it looked terrible, and I don't know why I did that. Um, okay. And so I guess the point of doing this is that we can combine this fact and this fact. Can we? Yes. Uh, should look. Oh yeah, I already read that. He can't be Keanu Reeves because he is me. Hey, obtuse, baboon, baboo. What the hell does this mean? Double rainbow. What does it mean? Oh, the inequality flips. Because I multiplied by a negative. That's important. Grunwall? I don't know who that is. Wait, well, okay, Leo, if you streamed while I was streaming, that's why. But I actually do need to say hi in one of your streams. I'm bad about checking my YouTube on like you did not? Okay, well, I do need to say hi. I just don't check my YouTube on this account that often. I don't hate you, Leo. There's a lot of people's streams I need to say hi in, and I haven't been because I'm just freaking stressed about my finals. You're watering up in the eyes already? Really? I haven't seen this before. But I don't think we're using that. So, AI slop streamer? No, you're not. Okay, so on the homework, where that was supposedly like the answer to this question, we get to this step here, and supposedly that just implies the exponential decay of the L2 norm. This is the L2 norm right here. It is... Wait. No. This is the change in time of the L2 norm. It's bounded above by a negative number that also decays exponentially because of the fundamental solution, because of my street math that I did apparently. Yeah, I'm cooked in chud and stupid and hot. People are saying chud now, and I don't know what it means. I keep seeing that word come up. Okay, that's good enough for me for number 2. Let's go to number 3. It's like an L2. Sorry, Leo. It means I'm old. You know, Skirtle, you're right. Oh yeah, this one was funny. So I noticed this myself, but I thought it wouldn't be allowed. For this question, if you answered f equals 0, you would have gotten credit, and some students did that because he didn't exclude a constant function, and f equals 0 does work. Your chunk too, whatever that means. Chunk with a C. And these numbers here, like, they mean nothing. Or at least, like, it doesn't necessarily look exactly like that. He just puts random shit in questions like this that he makes. So this is Poincaré's inequality again, and the question is really to find out what lambda of 0, 1 to the d is. Movie Backshots? I know what backshots are. I'm not that old. I hope you enjoy seeing some backshots, though. With all your friends. Um... You're welcome. Oop, I meant to. I'm so bad. I mean to write an F, but I make an integral. Like when there's an integral and F involved, I always do the wrong one. Okay. The choice of F we're going to make is sine pi x1, sine pi x2, sine pi xd. xd. Lols. So I guess grad F is pi cosine pi x2, x1, same thing. Sine pi x2, sine pi xd, comma, yada, yada, yada. Slowly lying about things that nobody cares about, just feel something in the uncaring world of second phases. Sounds good, Leo. Enjoy doing that. Okay, so then 0, 1, D. We can bring the pi out front. What the hell? I was drawing with my eraser. The magnitude. So these are all squared. Squared, squared, squared. Okay, we need to bound this above. Or something. We actually, no, I think we can actually calculate it. So orthogonality. Orthogonality. This evaluates to 1/2, that evaluates to 1/2, that evaluates to 1/2. And we have D many of those. So, hey Stooky, hope you're doing well. So we have D over 2 to the D? Question mark? Maybe? And down here we have 2 to the D? Oh, and I think that's good. It's a good thing. I think we just want... Well, it should be pi squared. Yeah, and it is pi squared. I just forgot. Okay. It's actually not homework. My last homework is already done and turned in for PDEs, thankfully. My PDE finals on Monday, and the class had 2 midterms, and he like sent us all the files for the midterms so we could use them to study. So I've been resolving both of the midterms. I'm all the way through midterm 1, and this is problem 3 out of 5 for midterm 2. And I think I've gotten the important part done. I figured that's the rationale for choosing f equal to sines. It's something with Fourier series. But this means for any choice of function f, I put the inequality the wrong way. Again. Wait, no I didn't. What? Wait. The inequality goes the other way here. Oh wait, but it might be supposed to be flipped. Um, hmm. Okay, you know what? We were allowed to take pictures of what we turned in. Let me see what I wrote for my answer here, because I'm getting confused now. Because I got this question right at the time. Uh, so okay, so what I just showed, I think, is this divided by this is wait. It's a Rayleigh quotient. Let's inequality is going the other way. So what I know that this ratio is always greater than or equal to pi squared d. It may not be the optimal one, but this is definitely true. Mmm. Okay. And so there exists functions that can be as large as we want above this upper bound. That's the idea. Wait, is that? And pi squared d is less than or equal to 10,000 e to the d, which is just random shit. I think this is the idea. And like this function definitely exists. Yeah, okay. And I gave an example of. See, you can make this as large as you want because you can name functions that have like a very small norm, but they get very steep. And so I think something like a really spiky Gaussian would get the job done. Yeah. The example I gave was the magnitude of x to the 1/3. I don't know if it's actually a good example the more that I think about it, though. Oh wait, it's over a bounded interval actually. Okay, yeah, I think that's fine. So I was thinking of like in one dimension, cube root of x, like it goes nearly vertical. So this thing should become very large while this thing is finite. Or it does go vertical. I don't know, something like that. I think I have the idea for that question. That's important, but problem 4. All right, this one wasn't too bad. Okay. You're supposed to non-constant function that solves this basic transport equation. My answer for that is u equals t plus x. Any function of t plus x would work. That's the simplest one, though. Non-constant, simplest one. For part B, if ut equals ux, then two things are true. Take the derivative in x of both sides. You get utx equals uxx. Take the derivative in t of both sides. You get utt is equal to uxt. But you can interchange the order of differentiation. And you get utx. So uxx equals utt. Bam. Problem 5. This one wasn't too bad either, actually. Okay. The notation for this is kind of a lot to work through. The actual answer is not that bad, though. So yeah, T is basically a set of vectors of all the possible in radii and diameters for convex sets. So a convex set means that it's a set where for every line you can draw between 2 points in the set, that line is fully contained in the set. So this like kidney bean set is not convex. I could take a point here and a point here, and this line is not contained in the set. Actually, you could make it convex if you kind of like cut that part out and put the border here. I think it's called like the convex hull of a set or something. The in radius of a convex set is the largest disk that fits inside of it. The radius of that disk. So like the radius of that disk there for this set. And the diameter is the longest possible value between 2 points on the boundary, so that would be the diameter there. One extreme case for this is a circle where 2 times the in radius exactly equals the diameter. The other extreme case is a long and narrow domain where you can make the in radius as tiny as you want, but the diameter as large as you want. And so we want to talk about the set of all possible in radii and diameters for this question. That's what this statement here is saying. So T of fancy C, probably math cal C, I said all points x, y in R2 greater than or equal to 0. That's a terrible 2. such that, so x is the in radius, y is the diameter, y needs to be at least twice as big as 2 of x. And I think that's it. Let me check with what I said at the time. Yep. That's exactly what I put for my answer. Okay. So there is... Ooh. Okay, sorry. There is a bonus problem on this midterm too. No one got it though, and I still don't really know how you do it, and I don't really care that much. It's about solving the heat equation backwards in time, which is possible, but it's like unstable. Like it's very difficult. I don't know if I really want to worry about this one. So I don't know how you're supposed to do it. And I feel like he probably wouldn't ask this again. He could, but I don't think so. Yeah, okay. I'm not gonna worry about that one. Yeah, that's a midterm solved. In 3 hours, but we had some distractions. We had 50 minutes for each of these. So that's pretty good time. I mean, I did kind of cheat and look at homework assignments, to be fair, but... that went pretty smooth, I think. I do need to look at Dirichlet's principle again. I might call it here, and it's about when I was planning to call it anyway, and I'm happy with what I've done so far for my studying. Yeah, I think we will. Okay, so people who are here on YouTube, thank you for being here. I don't know when I'll be back on YouTube, so good luck.